Trigonometric identities. Question 1. Determine which of the following are identities. Justify your answer. A. Secant of minus theta equals to secant theta. Well, let's look into it. When we say secant of minus theta, we are trying to check triangle in quadrant 4. This is like minus theta since it is going clockwise. And secant of theta will be a triangle or will be a point in quadrant 1, right? So we have two right angle triangles here. So one being in quadrant 1 and the other being in quadrant 4, right? Now, since what is secant? Secant is hypotenuse over adjacent side, correct? So if we take a point here as xy, then over here the point will be x minus y, but the radius or the hypotenuse will be r, correct? So what is secant of minus theta? Secant of minus theta will be x over r, right? And secant of theta will be x over r. We see both are equal and they will always be equal, correct? Therefore, this is an identity, correct? Because it is true for all values of x. Now, the only restriction here is that secant theta is actually equals to 1 over cos theta, right? So the values at which cos theta is 0, so where cos theta should not be equal to 0, right? So it is true for all the values except for cos theta not equal to 0, and therefore it is an identity. So for identities, it is an accepted fact that they are true for all values except for few restrictions. Restrictions are like I've shown here, okay? So A is an identity. Part B. Square root of 1 minus sine square theta is equal to cos theta. Now, well, some students get confused with it. They think like this. They think sine square theta plus cos square theta equals to 1, and therefore cos square theta equals to 1 minus sine square theta, right? And when we square root it, then we get cos theta equals the square root of 1 minus sine square theta. And the thing, it becomes an identity. You started with an identity and you land up here. Well, there is a mistake here. Do you know the mistake? The mistake here is that whenever you do square root, you have to write plus and minus. Now that plus and minus is missing. Do you see that? So that is why this becomes just an equation and it is not true for all values of theta. Another way to show it is like this. The left hand side, square root of 1 minus sine square theta is always positive, correct? Always positive. But in our quadrant, cos rule, correct? Cos is positive only in two quadrants, that is in quadrant 1 and in quadrant 4. But cos is negative in the other two quadrants. So for all the values of theta, if theta is between 90 degrees, greater than 90 degrees, and is less than 270 degrees, in that case this equation will not be satisfied, because we'll get negative value on the right side but a positive value on the left side. So it is not equal in entire domain. Therefore, this is an equation but not an identity. Okay?